After the universe got to the size of a melon, and remember, the universe today contains 350 billion galaxies, each with 100 billion stars, there was a time when it was as small as a melon. Michio Kaku is one of the most prominent voices in the world of theoretical physics, known for his ability to bridge the gap between the complex and the accessible. Kaku has spent decades exploring the mysteries of the universe, but his latest revelations about quantum physics have sparked a mixture of awe and concern. Quantum physics, the science of the very small, is not just an academic curiosity, it is a reality-shaping force that could have profound implications for humanity's future. What Kaku has revealed isn't just about the promise of quantum mechanics, it's also about the dangers that come with it. To understand why Kaku's latest statements are so alarming, we first need to delve into what quantum physics is. At its core, quantum physics is the study of the smallest building blocks of the universe. It deals with particles like electrons, photons, and quarks, entities so small that they defy our conventional understanding of reality. These particles operate in ways that are counterintuitive, unpredictable, and downright bizarre. They can exist in multiple places at once, teleport across space, and even influence one another instantaneously over vast distances. This is where the concept of quantum entanglement comes into play. When two particles become entangled, their states become linked no matter how far apart they are. If you change the state of one particle, the other reacts instantly, even if it's on the other side of the universe. Albert Einstein famously referred to this phenomenon as spooky action at a distance, and it is one of the key principles that underpins the quantum revolution. But while entanglement might sound like a strange quirk of the quantum world, it has very real implications for technology and society. Quantum entanglement is the foundation of quantum computing, a field that has the potential to revolutionize everything from medicine to artificial intelligence. Yet, as Kaku warns, the very same principles that could usher in a new era of progress also come with risks that we are only beginning to understand. Take quantum computing, for example. Unlike classical computers, which use bits to process information in binary form, quantum computers use quantum bits, or qubits. These qubits can exist in multiple states simultaneously thanks to a phenomenon known as superposition. This allows quantum computers to perform calculations at speeds that are incomprehensible by today's standards. In theory, a quantum computer could solve problems in seconds that would take classical computers millions of years. The promise of quantum computing is enormous. It could unlock unprecedented capabilities across a wide range of fields. New cures for diseases, optimized global supply chains, and revolutionary advancements in artificial intelligence are just a few of the promises of quantum computing. However, Kaku points out that this power comes with a dark side. Quantum computers could also be used to break modern encryption systems, effectively rendering all current cybersecurity measures obsolete. Imagine a world where every bank account, government database, and private communication is vulnerable to being hacked. That's the kind of future quantum computing could create if it falls into the wrong hands. Kaku has described this as a potential quantum arms race. Governments and corporations around the world are investing billions of dollars into quantum research, vying for supremacy in this new technological frontier. The stakes couldn't be higher. Whoever wins this race will gain unparalleled power, not just in terms of computational capabilities but also in terms of geopolitical influence. But what happens when this technology becomes so advanced that it spirals out of control? Kaku warns that we may be on the brink of creating machines that even we don't fully understand, let alone control. Another troubling aspect of the quantum world is its potential to challenge our understanding of reality itself. Kaku has spoken extensively about the philosophical implications of quantum mechanics, particularly the concept of the multiverse. Quantum physics suggests that our universe is just one of many, a single bubble in a vast multiverse where countless other universes exist, each with its own set of physical laws. This idea isn't just speculative, it's supported by experiments that demonstrate the probabilistic nature of quantum mechanics. When a particle is observed, it collapses into a single state, but prior to observation, it exists in a superposition of all possible states. Some physicists interpret this as evidence that every possible outcome of a quantum event actually occurs, each in its own separate universe. If this is true, it raises profound questions about free will, consciousness, and the nature of existence. Are we just one of an infinite number of versions of ourselves, each living out different possibilities in parallel universes? And if so, what does that mean for our sense of identity and purpose? Kaku argues that these questions aren't just theoretical, they have real implications for how we view ourselves and our place in the cosmos. But perhaps the most alarming aspect of Kaku's revelations is the idea that we may be tampering with forces we don't fully understand. Quantum mechanics operates on principles that are fundamentally different from the macroscopic laws of physics we experience in everyday life. And while our understanding of the quantum world has grown exponentially, there is still so much we don't know. For example, scientists have recently begun exploring the possibility of creating entirely new quantum phenomena, unlocking doors to realities that we can barely comprehend. Artificial black holes in the laboratory are not the gargantuan black holes found in space, but microscopic versions created by manipulating quantum fields. While this research is groundbreaking, it also raises serious ethical and existential questions. Could we accidentally create a black hole that grows out of control, swallowing everything in its vicinity? While most physicists dismiss this as unlikely, the mere possibility is enough to give pause. Then there's the question of quantum artificial intelligence. As quantum computers become more powerful, they could revolutionize AI, allowing machines to process information and learn at unprecedented speeds. This could lead to incredible advancements in medicine, engineering, and countless other fields, but it could also lead to the creation of AI systems that surpass human intelligence, a scenario that has been described as both an opportunity and an existential threat. Kaku has spoken about the dangers of runaway AI, where machines become so advanced that they begin to act in ways that are unpredictable and uncontrollable. In a quantum-powered future, this risk becomes even more pronounced. If we create AI systems that operate on quantum principles, their behavior could be governed by the same probabilistic rules that define the quantum world. This would make them inherently unpredictable and potentially dangerous. And it's not just AI that poses a risk. Quantum technologies could also have unintended consequences for the environment. Quantum experiments often require extremely low temperatures, achieved using cryogenic systems that consume vast amounts of energy. As the demand for quantum computing grows, so too will its environmental footprint. Kaku warns that we need to consider these impacts carefully, lest we create technologies that exacerbate the very problems they are meant to solve. But perhaps the most unsettling possibility is that quantum mechanics could one day reveal that our universe is not as real as we think. Some interpretations of quantum physics suggest that reality itself is a kind of simulation governed by underlying mathematical rules. If this is true, it raises questions about who or what created these rules, and why. Are we living in a simulated universe designed by an advanced intelligence? And if so, what happens if we start to tamper with the code? Michio Kaku has described this as the God question, the idea that quantum physics could one day lead us to discover the ultimate nature of reality. But while this prospect is awe-inspiring, it's also deeply unsettling. If we're living in a simulation, what happens if we break the rules? Could our attempts to manipulate quantum systems have unintended consequences that destabilize the very fabric of our reality? These are not questions with easy answers, and they continue to challenge our understanding of the universe. The need for caution as we explore the quantum frontier cannot be overstated. Kaku emphasizes that we are entering uncharted territory, and the stakes couldn't be higher. Quantum physics has the potential to unlock the secrets of the universe, but it also comes with risks that we are only beginning to understand. So, what can we do to navigate this brave new world? Kaku argues that the key lies in balancing exploration with responsibility. We need to invest in quantum research, but we also need to establish ethical guidelines and safeguards to prevent misuse. This will require cooperation on a global scale, bringing together scientists, policymakers, and ethicists to ensure that quantum technologies are developed for the benefit of humanity. Kaku also stresses the importance of education. The quantum revolution is happening now, and it is essential that we equip future generations with the knowledge and skills to understand and navigate this new reality. Quantum mechanics may be complex, but it is not beyond the reach of human comprehension. By investing in education and public awareness, we can demystify the quantum world and ensure that its benefits are accessible to all. In the end, Michio Kaku's message is both a warning and a call to action. Quantum physics is a double-edged sword, capable of unlocking incredible potential but also fraught with risks. As we stand on the brink of this new frontier, we have a choice to make. Will we use this knowledge to advance humanity, or will we let it spiral out of control? The answer lies in our hands, and the stakes couldn't be higher. The quantum revolution is not just a new chapter in physics, it is an entirely different book. Kaku has been a leading voice in explaining the enormous potential and profound risks that come with it. The discoveries in quantum mechanics over the last century have gradually peeled back layers of reality, revealing a universe that is not only stranger than we imagine, but stranger than we can imagine. Now, as we stand on the precipice of unleashing quantum technology into the mainstream, Kaku's warnings have never been more timely or more unsettling. At the heart of this revolution lies the concept of quantum uncertainty. In classical physics, we are used to the idea that objects have precise positions, velocities, and trajectories. If you throw a ball into the air, you can predict where it will land with absolute certainty, as long as you know its speed, angle, and external conditions. But in the quantum world, things do not work that way. Quantum particles exist in a state of probability rather than certainty. You can only predict the likelihood of a particle being in a specific place or having a specific momentum. This principle, called the HeisenbergUncertainty Principle, is a fundamental aspect of quantum mechanics, and it challenges our traditional understanding of reality. The Heisenberg-Uncertainty Principle challenges the very notion of determinism. According to Kaku, it's as if the universe itself is playing dice, something Albert Einstein famously disliked as he believed in a deterministic cosmos. But as quantum experiments have repeatedly shown, randomness and probability are fundamental to the way the universe works at its most basic level. Why does this matter to us? It matters because we're now building technologies that harness this quantum uncertainty. Quantum computers, for instance, rely on the fact that particles can exist in multiple states at once. This property, known as superposition, allows quantum computers to perform calculations on a scale that would be impossible for even the most powerful classical supercomputers. But Kaku warns that tampering with quantum uncertainty on a large scale could have unforeseen consequences. For one thing, we don't fully understand the long-term effects of manipulating quantum systems. When we observe or measure a quantum particle, its wave function collapses, forcing it to adopt a definite state. This act of measurement doesn't just passively reveal information, it actively changes the particle's state. In a sense, our observations alter reality. This isn't just a philosophical curiosity, it's a physical fact with potentially serious implications. As we begin to harness quantum mechanics for practical applications, we inadvertently altering reality in ways we don't yet comprehend. Kaku has described this as a kind of Pandora's box. Once you open the box, you can't close it again, and you may not fully understand what you've unleashed. For example, some researchers are exploring the possibility of using quantum entanglement for communication. This would allow for instantaneous transmission of information across vast distances, potentially revolutionizing telecommunications. But what happens when you start entangling large numbers of particles on a global or even cosmic scale? Could we accidentally create a network of entangled particles so vast that it begins to influence macroscopic events in unpredictable ways? One particularly chilling possibility involves the concept of quantum vacuum fluctuations. At the quantum level, empty space is not truly empty, it's a seething froth of particles popping in and out of existence. These fluctuations are usually harmless, but Kaku warns that large-scale quantum experiments could disturb this delicate balance. Some theorists have speculated that a sufficiently powerful quantum event could trigger a false vacuum decay, a catastrophic reconfiguration of the universe's fundamental structure. While this is purely theoretical at this point, the fact that it's even a possibility should give us pause. Then there's the question of quantum biology. While quantum mechanics is typically associated with physics, it also plays a crucial role in biological systems. For example, researchers have discovered that certain processes in photosynthesis, bird navigation, and even human consciousness may rely on quantum effects. This raises profound questions about the nature of life itself. If biological systems are fundamentally quantum in nature, what happens when we begin to manipulate quantum processes on a large scale? Could we inadvertently disrupt the delicate quantum mechanisms that sustain life? Kaku has also spoken about the ethical implications of quantum technology, particularly in the realm of artificial intelligence. As quantum computers become more powerful, they could enable the creation of AI systems that far surpass human intelligence. These quantum-powered AIs wouldn't just be faster or more efficient than current AI, they would think in fundamentally different ways. A quantum AI could process multiple possibilities simultaneously, making decisions and solving problems in ways that are incomprehensible to the human mind. While this might sound like a utopian vision of progress, Kaku warns that it could also be a dystopian nightmare. A quantum AI wouldn't just be a tool, it would be a new form of intelligence, potentially with its own goals and priorities. If such an AI were to act against human interests, it could pose an existential threat to humanity. And because quantum systems are inherently unpredictable, we might not even see the danger coming until it's too late. This unpredictability extends to the realm of quantum warfare. Kaku has pointed out that quantum technology could revolutionize military strategy, leading to the development of quantum weapons. These might include devices that exploit quantum entanglement to disable enemy communications or even quantum-powered missiles capable of evading detection. The prospect of quantum warfare raises serious ethical and geopolitical concerns. In a world where quantum technology becomes a tool of war, how do we ensure that it's used responsibly? One of Kaku's most alarming warnings is about the possibility of a quantum runaway effect. As we continue to push the boundaries of quantum research, we're venturing into uncharted territory. Kaku compares this to the early days of nuclear physics, when scientists were exploring the potential of splitting the atom. At the time, some researchers worried that a nuclear explosion might trigger a chain reaction that would ignite the Earth's atmosphere. While this fear turned out to be unfounded, it underscores the risks of exploring phenomena we don't fully understand. In the case of quantum mechanics, the risks are even greater because we're dealing with the fundamental building blocks of reality. If we were to inadvertently destabilize a quantum system on a large scale, the consequences could be catastrophic. Kaku warns that we need to approach this new frontier with caution, humility, and a deep respect for the unknown. But it's not all doom and gloom. Kaku also sees immense potential in quantum technology to address some of humanity's greatest challenges. For example, quantum computers could revolutionize medicine by simulating complex biological systems at the molecular level. This could lead to breakthroughs in drug development, personalized medicine, and even the treatment of previously incurable diseases. Quantum mechanics could also play a key role in addressing climate change. Quantum algorithms could optimize energy systems, improve renewable energy technologies, and even help us develop new materials for carbon capture. In this sense, the quantum revolution is not just a challenge, it's an opportunity to create a better future. However, Kaku emphasizes that realizing this potential will require careful planning and global cooperation. Quantum technology is too powerful to be left to the whims of individual nations or corporations. Instead, Kaku calls for the establishment of international agreements and ethical guidelines to ensure that quantum research is conducted responsibly. This includes not only preventing the misuse of quantum technology but also addressing its potential environmental impact as we develop more advanced quantum systems. We need to ensure that they are sustainable and energy efficient. Education will also be crucial in navigating the quantum future. Kaku believes that quantum physics should be a core part of science education, starting at the high school level. By demystifying quantum mechanics and making it accessible to the public, we can ensure that future generations are equipped to understand and engage with this transformative field. Ultimately, Kaku's message is one of cautious optimism. The quantum revolution is a double-edged sword, capable of both incredible progress and unimaginable risks. As we stand on the brink of this new era, we have a choice to make. Will we use quantum technology to uplift humanity, or will we let it spiral out of control? The answer lies in our ability to balance curiosity with responsibility, exploration with caution, and innovation with ethics. The stakes couldn't be higher, and the time to act is now. The quantum future is coming, whether we're ready for it or not, and as Kaku reminds us, the decisions we make today will shape the trajectory of human civilization for generations to come. Will we rise to the challenge, or will we become the architects of our own undoing? The choice is ours, and the clock is ticking.